In this question, we're told that the number of Summer Olympic medals won by a particular country are normally distributed with a mean of 91.917 and a standard deviation of 30.9247. We want to use Desmos to calculate some probabilities. A key piece of information to pick up on here is that if we're told that something comes from a normally distributed population, the probabilities that we want to calculate should be calculated using the normal distribution. So we'll open up Desmos. In this case, we don't need to plug in values for n and p like we would do for the binomial distribution. We need to plug in the values for the mean and standard deviation. So that was 91.917. And the standard deviation was 30.9247. Using the drop-down arrow, we can open up the normal distribution calculator and the cumulative probability tool, which will allow us to set up different types of probability statements depending on what we want to calculate. We can also turn on the normal distribution graph and click the Zoom Fit button to see the distribution and the corresponding probability that our statement is calculating. In part A, we want the probability that in a randomly selected year, this country won fewer than 121 medals. Something interesting to note here is that we want that to be specifically fewer than 121. So the accurate statement mathematically would actually be less than 121. But for reasons we won't really get into here, when we're dealing with the normal distribution or continuous distributions, whether this is a strict inequality or in this case a less than or equal to, it actually doesn't impact the result of our calculations. So if you were to catch that and think it looks a little funny, it is, but as it turns out, doesn't impact our calculations. So we want to find the probability that x is less than or equal to 121. That's going to be a left probability statement. So we want x less than or equal to 121, and we can output that full result to make sure we can round this appropriately to 0.8265. Then in part B, we want a restricted probability, not a restricted probability statement. We want a probability statement where x is bound between two values. That is, we want to find the probability that in a randomly selected year, this country won between 32 and 130 medals. So we want an inner statement, and let me double check my numbers here, 32 and 130. Once we have that probability set up, we can export that result, which is 0.8646, to calculate those appropriate probabilities.